So if you're looking to subtract rational expressions that have different denominators, the key is that you need common denominators, right? So that's going to be the first thing that we're looking at in all of these problems is how can we get that common denominator. So we can take a look at the first one, and we're going to get more difficult and more complex than this, but we see that 4 and 8 are not the same, but I can turn 4 into an 8 by multiplying by 2. But if I multiply by 2 over 2, which is a fancy version of 1, then I'm really not changing the problem. Think about taking your age, multiplying by 1, you still have your age. So I now have a 6 on top, I now have an 8 on the bottom. Now I have common denominators, sweet, 6 minus 1, easy. So the goal is that we need common denominators. On the second problem, when 4 doesn't go into 3 or 3 doesn't go into 4, you can simply share the other denominator. So the 3 will go over there, the 4 will go over there, and now 3 times 4 and 4 times 3 are going to give me the same thing, going to give me that 12. Now I can't just willy-nilly do whatever I want. A 3 over 3 is a 1, and now I'm not changing the problem. 4 over 4 is a 1, and now I'm not changing the problem. So now I have 3 times 1, which is 3, 3 times 4, which is 12, 2 times 4, which is 8, and 3 times 4, which is 12. I got common denominators, sweet. Now I can subtract rational expressions. 3 minus 8 is negative 5. Those are our examples as we now head to Algebra 2. How can I get these different denominators to be common? If I multiply this left one by a 2, 2 times 2x is going to get me 4x, and 2 times 5 is going to give me that 10. If I make this a fancy version of 1, 2 over 2, then I'm really not changing the problem. So now I have 2x plus 6. Notice that the distributing also happens on the numerator. On the bottom, I now have 4x plus 10. I didn't need to change the right side of the fraction because I already have 4x plus 10. And now I will go ahead and subtract. I got common denominators, sweet. Go ahead and jot those down. I have 2x's minus 6x's, which is negative 4x's. And then I have 6 minus 5, which is positive 1. On our right side, we have not common denominators. So is there a way I can get common denominators? If I multiply this left fraction by a 3, 3 times 3x is going to get me that 9x. 3 times 7 is going to get me that 21. And now I have common denominators. Don't forget, 3 over 3 is a fancy version of 1, so I'm really not changing the problem. And now I'll distribute the 3 to the 2x, and I'll distribute the 3 to the 1. All right, as I go to combine, keep in mind I have the common denominator that I need to go ahead and put that right in my answer. And then on the top, I have 6x minus an x, which is 5x. And then be careful here. I have 3 minus a negative 10, which is going to add, right? 3 minus a negative 10 is going to add. 3 plus 10 is going to give me a 13. And I'll finish off with a couple more where the denominators are not the same and there's some trickier parts to them. A lot of students will want to do 2 here so they can turn that 2 times 3 into the 6, but then it also changes the 2 times the x into 2x, and that is not what we have over on the side. So we're going to have to do what we did in that first warm-up. If I can't turn one into the other, I'm simply going to share the x plus 6 to this side, and then I'm going to share the x plus 3 to the other side. These are just really fancy versions of 1. And now I will distribute. 1 times x is 1x. 1 times 6, 6. I'm going to go ahead and leave the bottom as factored so I don't have to do a whole bunch more work. I'm going to go ahead and leave the bottom as factored so I don't have to do a whole bunch more work. But I do have to distribute. 5 times x is 5x. 5 times 3 is 15. Now I have a common denominator. I can head right to my answer. And I can just be careful as I'm going and subtracting step by step. 1x minus 5x is negative 4x. And then 6 minus a 15. 6 minus 15 is a negative 9. All right, and I head to my final problem. Is there a way to turn this one into that one? There's not. I could double it, get the 2x, but if I double the 5, that gives me 10, and that's not what I want. So let's just go ahead and share the other denominator. 2x minus 7, balance it out, 2x minus 7. That's a really fancy version of 1. And if I put the x plus 5 over here, over another x plus 5 over here, that will balance out on both sides. I can now see that I have a common denominator. My new numerator is going to be 4 times 2x, which is 8x. 4 times negative 7, which is negative 28. And I can go ahead and write down my common denominator. I'll go ahead and write down my common denominator over here. And make sure I distribute on the top. I now have 3x as my new numerator. I now have 3 times 5 as 15 as my new numerator. I got common denominators, fantastic. I'm ready to finish the problem. I'm ready to actually subtract. Just go slow, be careful, go step by step. 8x minus 3x, that is 5x. And negative 28 minus 15, negative 28 minus 15, that gives me a negative 43, and I have my final answer.